Welcome to This Explainer. We're jumping right into something literally all of us deal with every single day, but probably rarely stop to think about. We're looking at the relationship between our brains and sugar. Get ready, because the biological pathways that light up when you take a bite of something sweet, they're honestly as wild as any science fiction story out there.
But first, let's do a quick little experiment. I want you to just picture a plate of warm, gooey chocolate chip cookies, fresh from the oven. Or maybe crunchy, colorful candies. Or perhaps a velvety, rich chocolate cake. Actually, how about a waffle cone piled impossibly high with your absolute favorite ice cream? Is your mouth watering just picturing it? Are you suddenly craving dessert? If you are, the big question is, why? What exactly is happening up in your brain that makes these sugary foods so incredibly hard to resist? Spoiler alert, it's not just a lack of willpower. It's actually deeply wired biology. Section 1, Sugar Hiding in Plain Sight. Okay, let's dive into this. To understand your brain's reaction, we first need to understand the trigger itself. You see, sugar isn't just that white powder you spoon into your morning coffee. It actually describes an entire class of carbohydrates. And because of that, it hides under a pretty extensive list of names on ingredient labels. You've got glucose, fructose, sucrose, maltose, lactose, dextrose, and starch. These are all forms of sugar. And yep, so are high fructose corn syrup, fruit juice, raw sugar, and even honey. Because it goes by so many different names, sugar is incredibly sneaky. It is absolutely not limited to just candies and desserts. You're going to find added sugars hiding out in everyday pantry staples. We're talking tomato sauce, seemingly healthy yogurt, dried fruit flavored waters, and granola bars. Since it's practically everywhere, it's absolutely crucial we understand what it's doing to us neurologically.
Section 2, the biological journey.
So imagine taking a bite of sweet morning cereal. In a fraction of a second, this amazing biological relay race begins. The sugars immediately activate the sweet taste receptors right on your tongue. Those receptors fire a signal straight up into the brainstem, which then forks off into the cerebral cortex. That's the area that processes tastes like bitter, salty, umami, and of course, sweet. Finally, from the cortex, the signal triggers the brain's massive reward system, and this brilliantly illustrates just how fast our bodies react.
Now, this reward system is a deeply complicated network of pathways, but honestly, its entire purpose basically boils down to answering a single subconscious question. Yes, should I do that again? You know that warm, comforting feeling you get tasting your grandma's famous cake? That is literally your brain shouting, yes, more of this please. Section 3, the dopamine overdrive.
The real star of the show here is dopamine. It's a super important chemical neurotransmitter, and it acts as the major currency of our brain's reward system. Your forebrain is filled with these dopamine receptors, and they're clustered together in dense little hotspots. When a highly rewarding experience happens, whether that's hanging out with friends or eating something sweet, these dense hotspots just get completely flooded with dopamine. To really wrap our heads around sugar's power, we need to look at the extremes. Take eating a piece of broccoli. Broccoli has virtually zero dopamine effect. It doesn't light up those hotspots at all, which, probably explains why it's so incredibly hard to get kids to eat their veggies. But compare that to drugs like alcohol, nicotine, or heroin. Those substances send dopamine into a violent overdrive, causing people to constantly seek out that high, which leads directly to addiction.
So the crucial point is figuring out exactly where sugar fits into this whole picture. Believe it or not, sugar is actually quite rare among foods. It causes dopamine to be released in a way that places it uniquely right between plain vegetables and hard drugs. It triggers that release less violently than drugs do, for sure, but the nature of the reaction? It's remarkably similar. And hey, the journey doesn't just stop in the brain. Let's trace that bite of cereal even further down. It travels through your stomach and eventually reaches your gut. And guess what? There are sugar receptors hiding out down there too. They detect the sugar and send signals right back up to the brain, telling you that you're full or telling your pancreas to start producing insulin to deal with that massive sugar load. Section 4, the evolutionary glitch.
Now we arrive at the absolute most fascinating part of our explainer. Why on earth does the brain treat sugar so differently? Well, let's say you eat a standard, healthy, balanced meal. The first time you eat it, your dopamine levels spike. But if you eat that exact same dish many days in a row, the dopamine spikes actually become smaller and smaller, eventually leveling out entirely. The food just becomes boring. But if you eat a lot of sugar-rich food instead, that dopamine response simply does not level out.
To understand why sugar acts like a glitch in the system, we have to look at why dopamine levels off for normal food in the first place. The human brain evolved to pay special attention to new tastes for very specific survival reasons. First, to identify if food has gone bad. Second, getting bored naturally encourages dietary variety. And third, seeking out that variety ensures we hunt for different foods, making it way more likely we get all the diverse nutrients our bodies actually need. We are quite literally hardwired to get bored of healthy food.
But here's the catch. Overeating sugar acts as an evolutionary override. If you rarely eat sugar, it behaves just like a balanced meal. But if you eat way too much of it, it completely bypasses that natural leveling out process. It will continuously feel rewarding, no matter how often you eat it. And in this very specific way, it behaves a bit like a drug, kicking off a whole series of unfortunate events: loss of control, intense cravings, and an ever-increasing tolerance.
Section 5. The verdict on moderation.
So what do we actually do with all this information? Well, you just have to remember that every single time any form of sugar is consumed, whether it's raw honey, high fructose corn syrup, or that hidden sugar in your tomato sauce, it kickstarts that dopamine domino effect. And the golden rule is pretty simple. Too much sugar, consumed too often, equals dopamine overdrive. Overconsumption absolutely can have addictive effects on the brain.
However, the reassuring verdict is this: you don't need to be terrified of dessert. A wedge of cake once in a while won't hurt you. If you don't eat a massive amount of sugar at a time, your brain is going to process it just like a normal, balanced meal. Moderation is what prevents that evolutionary override from taking control.
As we wrap up, I want to leave a question echoing in your mind. Now that you've seen the highly structured biological journey of a single bite of sugar, and you know exactly how those dopamine hotspots in your brain are reacting, how might you change your next meal? Are you going to check the label on your flavored water? Maybe look at that tomato sauce a little differently? I really hope this explainer has empowered you with the knowledge to understand your own cravings. Thank you so much for learning with me today, and keep asking questions.